2 is about interpreting graphs. So we're going to begin with working example number 1, solve a problem using interpolation. And interpolation is a term that you need to understand, or to interpolate means to estimate a value between two given values. You only use this method when it makes sense to have a value that is between two given values. For example, 5.4 people does not make sense. You would either have 5 people or 6 people, but not 5.4 people. So for this example, we have a weather balloon that records the air temperature at different altitudes. Altitude is the height above ground. Or is the height in the air, which is above ground. The relationship between the temperature and the altitude is a linear relation, so it changes constantly and consistently. So the altitude, we're going to use the variable a to represent, and it's measured in meters. And we've got a chart here showing 350 all the way up to 1800 meters. And the temperature T in degrees Celsius, ranging from 11.4 degrees Celsius down to negative 10 degrees Celsius. We are told at an altitude of 600 meters, or actually we're asked, what is the air temperature? So if we look at the chart, 600 is not given on here, but because we have a linear relationship, we can actually calculate it, and we do that using, we can interpolate the approximate answer. So graphing comes in very handy with linear relations, because data is a straight line if it's linear. So we start by graphing the data, and so temperature is your vertical axis, and altitude is your horizontal axis, and we're going from a negative 10 up to, what was it, 11.4 positive here, so we need to have both positives and negatives on your temperature. And so 0 along here, we're going all the way up to 1800 meters. You can plot these points, 350 and 11.4. So find 350 and then find 11.4, and there's one dot. And we can do that for each of these points, and then you'll see that they make a straight line. You can draw a line joining them as well. So you can interpolate the graph, or the answer, by looking at the points on the graph and say, okay, well, we're being asked about 600 meters. We can find 600 meters very easily. It happens to line up on one of the lines here on your graph. So 600 meters, you can draw a dotted line from 600 meters straight up until you hit this diagonal line that we've drawn. At that point, you draw a dotted line over to the other axis, and then you will see that at 600 meters, you're at approximately 8 degrees Celsius. So if there was a point here, it would be 600 meters and 8 degrees Celsius. So the dotted line touches the axis at about 8 degrees Celsius is our answer there. And then, so the temperature at 600 meters is about 8 degrees. Now, it's an about. It's not precise, but it's pretty close. If we had an equation that represented this situation, we'd be able to actually calculate it exactly. But using graphing, which is what we're working on, you can get pretty close. So, part B, at what approximate altitude is the air temperature negative 7.5 degrees Celsius? So once again, go to your graph, find negative 7.5 degrees Celsius, and that's going to be right in the middle between negative 5 and negative 10. And start at that point and draw a dotted line straight across until you hit your diagonal line. That is going to be a point there. Then you can move up to the other axis to find out what number it's sitting on. And in this case, I would say that's about 600 or 1625 maybe, give or take. Again, that is why this is approximate. You can't pick a very specific number on here when you've got I don't know, what is that, a 1 centimeter space, and it ranges in 200 meters across that. So you're approximating. So the temperature at negative 7.5 degrees Celsius is approximately at an altitude of 1625 meters. And of course, we can use coordinates to represent all the dots along this line, and in this case, that would mean that it's 1625, comma, negative 7.5. So that's the basics of how we can use a graph to interpolate data. You now have a show you know to give a try. Go ahead.